Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello and welcome everybody to this week's episode of the DooDoo Divas Smells Like Money podcast. Today, we are visiting with Mark Anderson, a professional engineer and the CEO and founder of Icarus. We're going to be talking about something a little bit different today, but this is something ancillary that could be very, very helpful for wastewater treatment and plants. And for any of those folks out there who are interested in green initiatives, solar power, or maybe have put into place a sustainability, initiative for their firms and are looking for sources to make that happen, technology and bolting them on. And so without further ado, welcome to the show, Mark.
Well, thank you very much, Susan. Hello. Good morning.
Hello. So you've got something very, very interesting in the form of technology that I wanted to bring to the show today. And it has to do with solar energy and battery power and renewable energy and how what you've developed really enhances solar systems. You're not a solar provider, but what your technology does is it actually helps a solar system perform more optimally. So I'd like you to kind of explain that to our audience in how it works and how it can be incorporated. And then we'll get in a little bit later about how this can really benefit wastewater treatment plants that are in remote areas and especially island nations where power, especially if they're in the Caribbean where they might be impacted by hurricanes, where power and keeping things on the grid easily and affordably may be a challenge. So with that, take it away.
Sure. Thank you. So, Susan, what makes us different is Icarus is a hybrid PV thermal system for commercial photovoltaic installations. And what happened is we developed a heat extractor that is about the size of a regular PV panel for commercial applications. And our heat extractor fits inside the back of the PV panel, and it's designed to cool the PV panel because as PV panels heat up, their performance drops every day. So we set out originally to cool the PV panels to improve their performance, which we have done. Along the way, we discovered that we collect and store so much heat that we remove from the PV panels. We decided that there was value there and we should store it and make hot water so that we store thermal energy as well. Effectively, Susan, we end up doubling the energy output per square foot of the entire commercial PV array.
PV stands for those who aren't familiar with the term?
I'm sorry, photovoltaic.
Okay.
So those are the PV panels or the photovoltaic panels that you've seen going up on rooftops and parking lots and also ground-mounted installations out in open areas.
Okay. So how does something like this, how can it help with remote areas and getting into, like island nations or, not necessarily island, but places where getting reliable power is going to be a challenge? How does that help?
Well, if we look at island nations as a case example um, they're ideal for our application because, well, first of all, power is very expensive in island nations. Fuel, usually diesel fuel, is shipped to the island locations and offloaded and used to generate power with diesel generators. And that whole process is very, very expensive. And it's also not the cleanest method of generating power. A lot of island nations that are a little bit more advanced use a system called cogeneration, which
Right.
does help, a little bit more effective and efficient, and cost effective and efficient, and it creates hot water or even steam at the same time as it's creating power. Well, the way that we can benefit is, first of all, island nations have a small footprint. Obviously, they're not unlimited, expansive, ground. And earlier I mentioned that Icarus doubles the energy output per square foot of PV array. So just that fact alone allows us to, get more bang for the buck, or per the square foot. At the same time, it allows us to get more bang for the buck as well, because the additional equipment required to add our technology to a PV array is it's a little bit less than half the cost of the original PV array. So effectively, we double the energy output for just a little bit more cost.
Okay. So if someone has, now, is this something that goes on at the installation of a new, or can it be retrofitted to existing systems?
Great question. Both, actually. Of course, we prefer to go in with new installations because it's an easier installation. But for a ground mounted or a parking canopy, which you see, over a parking lot quite commonly, at least in California, they're all over the place now. Those types of installations are easy for us to retrofit. The other is the ground mounted, which is the most common for commercial settings. Those are in the field, maybe a brown field, converted, and those ground mounted installations are very easy to retrofit. The ones we don't like to retrofit, I'll point out, are rooftops, because when the PV array was originally installed on that rooftop, an engineering analysis had to be done for the extra weight, and that would have to be redone. And then we would have to remove the panels, bring them down to the ground, install the new equipment, and then bring them back to the rooftop to reinstall. That's quite a process, and we just choose to avoid that. So we don't retrofit rooftops.
Okay. One of the things that we spoke about before we came on the show was, the fact that I think a lot of people are concerned with the reliability of solar, and especially the wastewater treatment plant, because it needs a tremendous amount of power draw. That can solar power, in its original form, without what we're talking about here, can it actually generate enough power to sustain the plant to do what it needs to do? And so by bolting this on, if they've thought about that, can this actually help remove or lessen the need for them to rely on traditional forms of electrical power, such as what we were mentioning earlier, diesel?
Absolutely, it can lessen the reliance. To remove the reliance is case dependent. It depends on how much photovoltaic they're willing to install, how much space they have, all of those things. However, adding an Icarus system to a PV system that is planned or already installed at a wastewater treatment plant will definitely improve the reliance of the solar and reduce the dependence on the grid at any location, because you are increasing the power output and also providing hot water, which is another benefit for wastewater treatment plants.
So let's talk about the numbers, because I'm sure that's the thing that's going to cross everybody's mind. Like, oh yeah, this is another capital improvement thing that I've got to add on to another expense. So you said to me earlier that you had some slides, and I took a look that they show some numbers. If you want to share the screen for those of us who are just listening, Mark will review these numbers audible. But for those of you watching, you're going to get that benefit, or you may want to tune back in and just catch the video portion of this to take a look at the cost savings and what you're going to be looking at as far as investment, and then what you'll save in electricity, because everybody's going to be concerned about the ROI. Is this going to mean a cash outlay? And if I do a cash outlay, how quickly am I going to get my investment back? And can this pay for itself in energy savings?
Sure. Well, let me go ahead and do that and share my screen. I'm going to turn my attention over here. This is a few slides that we've put together regarding wastewater treatment and specifically how we would impact in wastewater treatment applications. What's good is we can create, even solar by itself without Icarus is able to create a lower cost power for the treatment facility, right? Remember, their option in an island nation is generally diesel generated power, which is very expensive and not very clean. So by installing solar, they immediately are going to reduce the cost of power generation significantly. They're also going to be eligible for tax credits and investment tax credits that are coming out, depending on where they are, and what nation they may be, Susan, whether they're in Hawaii, for example, which is, of course, part of the U.S., or Puerto Rico, or if they're perhaps in Haiti, which is an entirely different government and entity. Wastewater treatment plants use a lot of power, right? As you know, we talked a little bit about the lift stations required to pump water, and they require a lot of power. They're all different. They're all different size, so I can't give you a specific number, but they also heat the sludge to about almost 100 degrees Fahrenheit, which is, in some cases that could be a 40-degree lift from, say, 60 degrees Fahrenheit to 100. So they would be using diesel fuel or natural gas or electric hot water to heat that hot water and for the sludge treatment. Very expensive process. I mentioned the tax credits. I would point out that Hawaii has a 22% tax credit for clean energy initiatives through 2025, for a good example. And they are trying to achieve 100% clean energy in the entire island by 2045.
Wow.
In order to do that, they're going to need a lot of solar power. I mean, there's wind and there's other sources as well, but they're going to need a lot of solar. And if you think about it, they are probably using propane to heat water in many cases in Hawaii. And instead of that, a system like Icarus can provide the hot water almost as a byproduct that is needed for hotels, hospitals, commercial facilities, food processing plants of all types at a very, very low cost. And I'll give you some examples of cost here in a moment. I'm going to move to another slide.
But before you move on,
Yes.
I just wanted to address this. Okay, I just wanted to go back to a lift station.
Yes.
And so are you suggesting that, I have seen this where there's one tiny array on a pole or on the roof of a lift station. And so this could be used in conjunction with that small array on a lift station very, very effectively. Even if they didn't want to incorporate something like this at a wastewater treatment plant, a good starting point could be a lift station?
Yes, absolutely it could. Be careful about when you say you see very small ones, because we're not sure whether they're just providing signal power, for example, like um, for the electronics, or are they actually powering the pump? Or the third possibility is that they are storing electrical power in a battery for the lift station. All three of those things could be used in conjunction with grid power for that lift station. Okay.
Okay.
Now, that is a good starting point. And in my um, little bit of research that I've done for lift stations, I can see that, well, I know that pumps require a significant amount of power. But in an island case, a lift station, if we had, let's say, 20 solar panels, 20 commercial sized solar panels, 300-watt panels, that would be 6 kilowatts of power. Okay. That's a fair amount of power for a pump at a lift station. That doesn't take up too much space. It's a fair rooftop, if you will, on a medium-sized home, I would say. Okay. That would be enough power to fully power that lift station, also to provide backup power for the lift station for rainy days using a battery backup system, and also provide hot water to someone in that local area if they were using a Icarus system.
Okay.
Does that make sense?
Yes, it does. Thank you.
Okay, you're welcome. And I want to also point out that all of that would be done at about 50% additional costs from the original PV installation. So if that 6 kilowatt PV installation, now I don't have numbers handy for you on island installations, but I can get pretty close. I would say $3 a watt installed for the original PV plant. Okay. That we're talking about, that 6 kilowatt PV plant for that lift station. That should be about an installed cost in an island nation, I would guess. It might be a little bit low, but certainly we would be less than that, 50% less than that in the US, okay? So if we said $3 a watt for those 6 kilowatts, you're looking at about $18,000, okay? To add the Icarus system and double the energy output, you're only going to add, in that case, maybe $6,000 more. That's where our beauty is. Now, if that was in the US, that whole system would be installed at $2 a watt, $12,000 total cost. It would still cost $6,000 to add the Icarus system. Okay, so the bang for the buck is better in the island nation. Does that make sense again?
Yes.
I'm
Yes.
trying not to get too far into the woods here, but
right. But as I know, just wanted to kind of touch on that, because the numbers, and can this pay, is this a worthwhile investment? Can it pay for itself? And will it reduce my energy costs overall, that I'm going to recapture whatever I invest in it over the long term?
Susan, you brought up a great point. I'd like to expound on that just for a moment. The return on investment of a typical, okay, we're going to talk about US based,
Okay,
because
let's
those
do
are
that.
the numbers. Typical commercial solar installation for a business owner is probably 6 to 7 years with a battery system. 7 years. Okay.
Okay.
Icarus can cut that in half, because we're producing more power, we're providing hot water. A lot of the things that we do enable him to use our power and water at peak demand time when the rates are the highest. So he really recoups his investment in a much shorter period. And when, as you know, a small business owner is hard pressed to make an investment that's going to take 7 years to pay him back. But when you're talking about 3 or 3.5 years, you really begin to get their attention. And
That's a
that's what
good
we're able to
yeah,
do.
it's a good point because everybody's like, I'd like to be greener. I'd like to have a sustainability initiative. But at the end of the day, especially with smaller municipalities, budgets are shrinking all the time. It's all going to come down to the numbers and how fast can I get that investment back. And I'm meeting my initiatives at the same time. But it all will come down to the dollars. And so thank you for, highlighting that. Something
Sure.
that you wanted to show another slide, but then there was something that we spoke about that I want to make sure that we touch on before we run out of time, was that you mentioned to me that in 2023, and I can't remember where it was that you mentioned, that there is a law now that they are not going to be allowing any natural gas to be put into any new construction, meaning apartments, homes. I don't know if that would apply to restaurants, because they need gas cooking for like chefs or, maybe there's a loophole for them. But for homes, that, wow, how this is going to impact development.
Susan, you're talking about the state of California, and that
Okay.
begins.
Which is a big
It,
state, big state.
yeah, it's the biggest population for sure in the country, and almost, well, I guess 40 million people, and it's a huge step taken by the state of California. Many people think the step is too big, and it begins in just a few days. Today's the 28th of
Right.
December. It's effective January 1st, and you had it right. It's new commercial and residential construction will no longer be able to install natural gas appliances, meaning your gas hot water heaters, your gas stoves, and your other, gas grills and other gas appliances. But in commercial settings, it also counts. So the hospitals, the hotels, the food processing plants, restaurants may have an exclusion, or they may have to use another source like propane or new electric. The objective is to get full electrification. So I don't know about any special cases like for restaurants, but I do know that commercial and residential new construction will no longer include natural gas appliances. And that's a big step taken by the state of California. And it's a bold step as well. But it's
you made it was because they're just trying to change that reliance on the fossil fuel to deal with the shortage of the natural gas, the emissions that come from it. So they're basically prohibiting it. But then that is going to make electric from standard sources very, very expensive. So, I'm just seeing that, wow, for any wastewater treatment plants or cities that are looking to build a new building, upgrade a facility, anything where natural gas, heating, hot water is going to be incorporated, that even having a small solar array outside of their building to deal with substituting the natural gas to power those, having a system like this on it is just going to make the solar that much more powerful and more cost effective overall.
You really understand the impact of what we're talking about with this new law. Those types of businesses are the ones that are going to bear the brunt of this, new challenge, right? Without having natural gas to rely on, and maybe they have to use electric hot water heater. Or Susan, maybe this is a windfall in a perfect storm for technology like Icarus that can improve the PV output while it's creating hot water and generating and storing hot water for those same types of commercial businesses, which is our target market, by the way.
Right.
It's our beachhead, just so you know, if you don't mind, our California multifamily housing, new construction for that exact reason, because beginning in January, they won't be installing natural gas, but they're going to still build 50,000 new units next year, as they do every year. And those people are going to come home from work and want to take showers, and they're going to need their hot water. And it's either going to be from electric sources or solar sources, as far as I can tell right now. So Icarus it's a perfect opportunity for our technology. And the California Energy Commission has been very good to Icarus. We've won 4 awards and grants from them already, and they recognize what we're doing, and they are paying for the installation of 3 of our new projects to demonstrate how well we can do this.
I love this. And this was the other reason why I wanted, you to come on the show, because I also saw an opportunity for those folks who are connected into the wastewater industry that are doing residential work under that classification of either plumber or PHCC, heating, cooling, heating, cooling, air conditioning. So that when they have to retrofit or do a remodel, or they're involved in a project, that this is a technology that they need to be made aware of, so that if on a new installation or a retrofit or a repair, that this is something that now that they can make their customers aware of, that, hey, I can't replace this natural gas heater because of this law. You have to go to an electric one, but I can make it more efficient for you if you do this.
Right.
Let's install a small solar panel, a little small, a solar installation outside the house, put one of these things on it, and maybe it'll handle your dryer. Maybe it'll handle your water heater. And I just love the fact that not only is it making the panel more powerful,
right,
but that it's taking the stuff that it generates, we were saying the heating, and instead of just letting it go to waste as a byproduct, it's actually turning a usable power source or resource out of something that normally would just kind of be wasted as a byproduct of solar power collection.
exactly.
And that ties in right into that. I love this. A lot of people are starting to adopt this, the triple bottom line. And for those who are not familiar with it, is adopt those companies or those organizations that are looking at trying to adopt a triple bottom line, meaning, if you're not familiar with the term, people, planet, profits, in that order, not the other way around, which a lot of corporations, it's the other way around. But that by doing that, we're actually paying ourselves back by using something that Mother Nature is giving us, adopting technology such as yours to harness what is already there. That before we had this technology, it was just being wasted. So I love this. It's giving us an opportunity to, I would say, what's that old expression? One man's trash is another man's treasure.
Exactly. You're right on with that, Susan. And I should point out that I didn't really tell you earlier, the way the system works is we originally set out simply to cool PV panels because they get so hot during the day. And as they heat up, their performance drops. It drops about 25% every single day. So their output drops 25%. Well, we set out to keep them cool and cut that drop in half. And I mentioned earlier that we proved we were able to do that. Well, what happens along the way is we collect so much heat and store it that it's very usable. In addition, by keeping the panels at a constant cooler temperature, we're extending their lifetime. Maybe we're bringing them from 20 to 25 years or 25 to 30 years. Not only that, but the panels have a lifetime performance curve where they start up here perfect at day 1, but at year 10, they've lost some of their ability to produce power. At year 20, they've lost more. Well, we can bend that curve back up so that because we've kept them cool the entire time, they don't lose nearly as much of that power output over time. So not only do we extend the lifetime of the panel, we improve the lifetime panel performance as well. And I felt it was important to add that to this part of the discussion.
I was not aware that they lost their capabilities.
Yes,
you know, when we drive, I know when you
Age.
drive, when you drive along the I-10 from California to Arizona, which is where I live, you see this, I forget where it is, but it is this giant field. At first, I thought it was a lake that was reflecting,
Right.
because you see all the reflect. And then as you get closer, you realize, oh, that's not a water body reflecting the sun. That's a giant solar collection farm.
It's a huge farm. Absolutely.
Yeah.
But they do. It's age degradation. Over time, they lose their ability to perform because of that heat fatigue, that cycle. Every day they get very hot, they cool back off. That reduces their ability to produce power in the future. And so we help to offset that as well.
Wow. Well, Mark, I want to thank you for, coming on the show, telling us about the technology, but also, just a great little, what I would call solar power 101 education as to, I think some of the things that we shared today or spoke about, a lot of people are not aware of solar, and what it does, and some of its limitations and what happens. Like I never knew about the fact that it generated so much heat.
Sure.
All these little nuances about solar power. And
only those in the industry really know some of those things.
Right. And it's important to educate ourselves as we all are looking to be better stewards of the planet, looking for alternative energy, looking for better ways to do things. So again, thank you for coming on and sharing your knowledge. For those of you who might be interested in learning a bit more about this or opening up a dialogue with Mark, he is on LinkedIn. Look him up. And if you would please tell us the name of your website so that they can see. It's icarusrt.com, correct?
That's right. www.icarusrt.com.
And it's icarusrt.com.
Exactly.
So again, thank you everybody for tuning in to this week's episode of the DooDoo Diva Smells Like Money podcast. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.